memory. So sometimes when you allocate memory, you there's data still left behind where you allocated the memory. Calloc, this function does the same thing, but it sets the memory to 0. So malloc is like if you're renting an apartment or like a tenant left some stuff behind, and calloc is getting like a freshly empty apartment. So I'm going to discuss these. So this is the code I wrote. This is common stuff you're going to be libraries you need to include. Standard library is the memory allocation functions like malloc, calloc, realloc, and free. It's free memory, freeing the memory allocation. So this is just um, a function, and when I run this, it's the correct uses of malloc. So you I'm going to allocate memory for an integer, and I have a pointer equal to that's pointing to the allocated memory space, and it's the size of an integer. And so you always do this error checking if the pointer is null, and then that means the memory allocation fails, and then you just you exit. So you have you set the allocated memory, you set it to like say 100. That's a number, it's an integer, and then you print it out. And then when you're done, you want to free that allocated memory. You always want to do that. You don't want that you don't want the memory any. Um, you want to be able to use that memory in the future. And so this is another example. You allocate a memory of an array of integers, and so I just set that. I set this number of elements to 5, and I create a pointer, and the pointer is pointing at allocates memory, the size of an integer, and there's 5 of them, the size of the array, and you always check if malloc succeeds. If this is pointing to a null, then the memory was not allocated for that array. And I created a for loop, and like 10 through 50. It's just going to have I created each value in that memory, and the allocated memory. Each array, each integer is going to be put in there. I just do a little calculation and put it in there, and then I print it out. These the percentage D, and string is percentage S, and then the indentation, and so it just prints out the where they are in the loop, and the value that's actually put, the calculated value that's put in the array. That's the index, and that's the value. And then allocate the memory when you're done. When you use malloc, you need to free that memory. So you're freeing that allocated memory. And so I allocated memory for a string. I do the same types of things. And so the string length is 20. And so because you want to make sure that you have the null terminator at the end of a word. So you'll use string when you allocate the memory, you add 1, the string length plus 1 for the null terminator. Read that now. So a common problem is a memory leak. So this is when the allocated memory is no longer reachable. like when the pointer is lost. So this is okay if you free the memory because you can use a memory somewhere else. Um, but if you don't free the memory, then it's a memory leak. So that memory remains occupied until the program terminates. So so I created a leaky pointer, and and, the its point is allocating the size of an integer, and so I print out the address. So instead of freeing, so I let it equal. Normally you would free it. So now I'm going to set it to null. Okay. So when you set the pointer to null, and I think when I compile, it's going to raise a warning. Um, but So this is a leaked pointer. So it's pointing to null now. Instead of freeing it, it's just pointing to null. So like in a normal program, when someone's not paying attention to the allocated memory, this will happen when the pointer is overwritten. It goes out of scope without free being called. So you always free it before losing the pointer. So this is somewhat and here's another problem with allocated memory is double free. So you allocate memory, allocated memory the size of an integer, um, and then always check, and then double free equals 99. So there I print it out. So I allocated memory, and I free it, which is okay. That's what you're supposed to do. And then I free it again. So I free it right here. I commented out because it causes a segmentation fault, but not always. But it should cause a segmentation fault, and sometimes it's just undefined behavior, depending on what it's compiled with. Um, Undefined behavior is just as bad because it's it's garbage data. It's basically it's going to give you garbage data. It's not going to give you anything that you can use for anything. So so then after you free, it's called the dangling pointer. So when you free it and you try to use that memory again, that's a dangling pointer. Okay, so you free it and then you try to access the memory again. It's a dangling pointer. So that memory could have been already reallocated or it could become invalid, and it leads to corrupted data or segmentation fault. So integer dangler pointer, I created allocated a space for this dangling pointer. Error check, make sure it's not null, and I set it to 77, so it's okay. I freed it, which is fine. Okay, and so I go and I access, I print out the value of it after I freed it. And this is undefined behavior. So this is, we don't know what it's going to print. Uh, it just depends on what the operating system did with that block of memory, and what it's being used for. If it could have been reallocated, but it could be something. Um, so we just don't know what it's going to print out, but we're going to see. Um, so one way to make sure is after you free it, you can just set that pointer. Um, After you free it, um, you can set it to null. So And so, I mean, some people would disagree with this, but by doing this, if you try to access it again, this would cause the program to crash. I commented out. But some would feel that causing it to crash is better than getting corrupt data. So, like if you're running a program and you're getting data and you're writing down the data, it would have been better if it would have crashed. Stop the program so you know something's wrong rather than giving you data that's not accurate. That's unpredictable behavior. So by setting it to null, then you try to access it, it's going to crash the program. Um, and this is a buffer overflow, and sometimes this happens with like dynamic arrays. Um, um, this writes beyond allocated bounds. So I created a allocated memory for three integers, and so I just created a for loop, and then and then I I purposely created another space at the end of the array is only three integers, but I created a fourth integer in that same array. This is a buffer overflow. Um, so it's unpredictable behavior. It oftentimes it's a segmentation fault. So it's so that's a buffer overflow, and then so so calloc is similar to malloc. It allocates and initials everything to zero. Um, so I allocated five integers, and then I printed it out. Read it, and realloc is it changes the size to um, changes the size of, of memory that's already been allocated. Um, so it tries, and this one could turn null if it doesn't work. So it starts with three integers, and then you attempt to resize it to five. So you realloc that same memory block. Fails, you just free the memory. I'm just giving you a basic introduction to this. You can go into more detail. Um, this is this updates the pointer to the new block. It's assigned the values to the new elements. And you free the reallocated pointer. This shrinks the memory block down to from five elements to two, and then got to be careful when you do that not to access out of bounds. You have to be really careful of all that. Doing something like this, realloc, malloc, and calloc is it gives you practice. If you when you're printing it out and seeing and making mistakes, you kind of get a better understanding of dealing with memory and see and what you have to do. You got to get really good at this. This is realloc with size zero is like freeing something. So, um, anyways, you can also read through my notes, so you so I'm not having to spend all this time, but you can read what I put on the screen. Okay, so let's run it like this. Okay, so this is when we allocated memory for 100, and then I freed it, and then we allocated memory for 5 integers, and we did that little calculation, and we freed it. Straightforward. So this is a memory leak. I allocated the memory. The address was the operating system put it at that place in memory, and but that's so basically setting it to null. It creates a leaky pointer. Um, Now this one was one I was um, I was looking at this one. This is when you free something and then you free it again. Um, so so I'm gonna go ahead and compile that. So I compiled it with the second freeing the pointer, and then I'm gonna run it. And so it just caused it to it just caused it to crash. Okay. So that just undefined behavior. It causes it to crash in this system. Um, Piled it, and now I'm going to run it. Now we're looking at the okay. So now we're at 3. Common problems 3. So you see right here, value at dangling pointer after free. So they freed it, and then we're accessing it again, and it gives you this weird number. So and it's not, and that's why it's sometimes better, like in the other situation, it just stopped the program because if this data is being written somewhere and something else is reading the data and writing it, it's not going to know that this is garbage data. So this is undefined behavior. This number doesn't mean anything. What is this? Um, it probably does mean something, but it has nothing to do with this program. It has nothing to do with the value that was put there, 77. That's for sure. It has something to do with something else in the system. Um, but for our purposes, it's garbage data, and we don't want it. And it's better if the program had stopped to notify us of it, but it didn't. So that's what we mean by undefined behavior. So here's a buffer overflow. Let's see. So I created a buffer overflow, but it didn't really. So I thought, okay, so yeah, so it is undefined behavior, but I overwrote the array, so I overwrote memory, and then I freed the array, but still I wrote in memory. There's a space in memory that wasn't allocated. That and sometimes in some systems it would cause it to crash. This is just ignored it. I mean, it didn't show any obvious signs. Well, it didn't cause it to crash. So this is just calloc. Um, so it shows you how it's uh, initializes everything with zeros right there. And so yeah, so you put three more elements in there, and you see so basically I calloc, and then I resized it to five integers, and then I shrinked it down to two with calloc. And of course, you have to free the memory. I've been going into too much more detail. There's a So that's it for malloc and calloc. It's just an introduction, and of course you can do your own coding and play around with it and see what you can learn from it, and see if your system crashes or is a segmentation fault when you compile. Um, you don't have to use the strict compile that I used, but you want to use some sort of standard. But sometimes there'll be in your future you'll probably have some programs where you don't want strictness. It's depending on what computers and servers you're working on. I'm using a newer computer, newer operating system, so you know I'm not using an old server or anything. I'm pretty confident my code was going to pass a lot of stuff. Um, but yeah, that's a introduction, a little more detail to malloc and calloc.